Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshala Ogundele. Artificial intelligence, a change agent and disruptor of all aspects of humanity's endeavor. The focus points of my presentation are as follows: artificial intelligence and capabilities of intelligence systems. Over the centuries, starting from the first millennium BCE, philosophers such as Aristotle, Euclid, William of Ockham, and Duns Scotus, and a host of others have been developing the ideas of structured methods of formal deduction, a finite sequence of formulas in which each formula is either an axiom or is obtained from previous formulas by rule of inference, algebra, algorithm, and reasoning. Between the year 1232 and 1315, Ramon Llull developed several logical machines devoted to the production of knowledge by logical means. He described his machines as mechanical entities that could combine basic and undeniable truths by simple logical operations, produced by the machine through mechanical means in such a way as to produce all the possible knowledge. The possibility that all rational thought could be made as systematic as algebra or geometry was explored in the 17th century by Leibniz, Thomas Hobbes, and René Descartes. The real breakthrough in artificial intelligence came in the 20th century based on the study of mathematical logic. Artificial intelligence, the intelligence of machines or software, as opposed to the intelligence of humans or animals, is based on the assumption that the process of human thought can be mechanized. Research findings show that various traits and capabilities are expected of intelligent systems, and they are expected to display, and some of them are knowledge representation, reasoning and problem solving, learning capability, planning, decision making, social intelligence, and many more. In order to achieve the intended capabilities, humans develop algorithms for machines, which will enable them to imitate step-by-step reasoning that humans use when they solve puzzles or make logical deductions, and to use input from sensors such as cameras, microphones, wireless signals, active lidar, sonar, radar, and tactile sensors for proper deduction of the happenings in the world. Artificial intelligence is the ability of machines to perform tasks that are typically associated with human intelligence, such as learning and problem solving, and is presently gaining momentum. AI applications include advanced web search engines such as Google Search, recommendation systems such as YouTube, Amazon, and Netflix, understanding of human speech such as Siri and Alexa, self-driving cars such as Waymo, generative or creative tools such as ChatGPT and AI Art, and competing at the highest level in strategic games such as chess and Go. Simon AI robot designed to assist astronauts on the International Space Station is shown in this picture. Artificial intelligence goals are for reasoning, knowledge representation, planning, learning, natural language processing, perception, and support for robotics. AI long-term goals are general intelligence, that is, ability to solve an arbitrary problem. Illustration of space junk is shown in this picture. An AI has been harnessed to address the problem of space junk. Capabilities of intelligent systems. Various capabilities of intelligent systems are human assistant, planning and decision making, perception, learning, language processing, knowledge representation, problem solving and reasoning, and intelligence. Human assistance. Through robotics, AI machines are helping and assisting humans. Robotics, an interdisciplinary branch of electronics and communication, computer science and engineering, involves the design, construction, operation and use of robots. Illustration of space exploration with the assistance of artificial intelligence is shown in this picture. To design machines that can help and assist humans is the robotics goals. Robotics integrates fields of mechanical engineering, electrical engineering, information engineering, mechatronics, electronics, and biomedical computing. The field of robotics develops machines that can automate tasks and do various jobs that a human might not be able to do. Illustration of artificial intelligence being used in space exploration is shown in this picture. The robotics intelligence capabilities allow them to be used in inspection of radioactive materials, bomb detection and deactivation, manufacturing processes, or where humans cannot survive, such as in space, underwater, in high heat, and cleanup and containment of hazardous materials and radiation. Use of artificial intelligence in human day-to-day activities is shown in this picture. Agriculture, AI-assisted robots in agriculture, construction, industry, domestic, military kitchen automation, cleanup, and of contaminated areas, sample analysis, economics, and a host of others. Use of artificial intelligence in Earth is shown in this picture. Planning and decision making is another capability of intelligence systems. Artificial intelligence helps in planning and decision making. AI planning concerns the realization of strategies or action sequences, typically for execution by intelligent agents, autonomous robots, and unmanned vehicles. Unlike classical control and classification problems, the solutions are complex and must be discovered and optimized in multidimensional space. Planning is also related to decision theory. The picture here shows artificial intelligence as personal assistant in space. A Markov decision process has a transition model that describes the probability that a particular action will change the state in a particular way, and the reward function that supplies the utility of each state and the cost of each action. Game theory is another capability of intelligence system. Game theory describes rational behavior of multiple interacting agents and is used in artificial intelligence programs that make decisions to solve involving other agents. Demonstration of the use of AI in automation is shown in this picture. Learning is another capability of intelligence system. Machine learning is the study of programs that can improve their performance on a given task automatically. It has been a part of AI from the beginning. There are several kinds of machine learning. Unsupervised learning analyzes a stream of data and finds patterns and makes predictions without any other guidance. Impact of AI in Industry 4.0 is shown in this picture. Supervised learning requires a human to label the input data first and comes in two main varieties. Classification, where the program must learn to predict what category the input belongs in, and regression, where the program must deduce a numeric function based on numeric input. The agent is rewarded for good responses and punished for bad ones. The agent learns to choose responses that are classified as good. Side view of a Waymo-branded self-driving car powered by AI is shown in this picture. Transfer and deep learning. Transfer learning is when the knowledge gained from one problem is applied to a new problem. Deep learning uses artificial neural networks for all of the types of learning. Computational learning theory can assess learners by computational complexity, by sample complexity, or by other notions of optimization. Various applications of AI is shown in this picture. Perception is another capability of intelligent systems. Machine perception is the ability to use input from sensors such as cameras, microphones, wireless signals, active lidar, sonar, radar and detector sensors in order to deduce aspects of the world. Computer vision is the ability to analyze visual input. The field includes speech recognition, image classification, facial recognition, object recognition, and robotic perception. The picture here shows automation data analytics with 3D rendering of AI robot. Language processing is another capability of intelligent system. Natural language processing allows programs to read, write, and communicate in human languages such as English. Specific problems include speech recognition, speech synthesis, machine translation, information extraction, information retrieval, and question answering. Illustration of satellite making use of artificial intelligence is shown in this picture. Modern deep learning techniques for language processing include word embedding, transformers. In 2019, generative pre-trained transformer, referred to as GPT, language models began to generate coherent text, and by 2023, these models were able to get human-level scores on their bar exam, SAT, GRE, and many other real-world applications. A patient-sized surgical arm of Da Vinci's surgical system using AI is shown in this picture. Knowledge representation is another capability of intelligent systems. Knowledge representation and knowledge engineering allow AI programs to answer questions intelligently and make deductions about real-world facts. Formal knowledge representations are used in content-based indexing and retrieval, scene interpretation, clinical decision support, knowledge discovery, and other areas. Use of artificial intelligence for natural language processing is shown in this picture. Knowledge representation is another capability of intelligent systems. Knowledge acquisition is the difficult problem of obtaining knowledge for artificial intelligence applications. Modern AI gathers knowledge by scraping the internet, including the Wikipedia. For example, large language models such as ChatGPT. The knowledge itself was collected by the volunteers and professionals. The crowdsourced technique does not guarantee that the knowledge is correct or reliable. Illustration of robots with AI capability for space exploration is shown in this picture. Problem solving and reasoning is another capability of intelligent systems. Early researchers developed algorithms that imitated and mimic step-by-step reasoning that humans use when they solve puzzles or make logical deductions. By the late 1980s and 1990s, methods were developed for dealing with uncertain or incomplete information, employing concepts from probability and economics. Mars rover having AI capability is shown in this picture. Many of the early human reasoning algorithms are insufficient for solving large reasoning problems because they experience a combinational explosion. They became exponentially slower as the problems grew larger. Humans rarely use the step-by-step deduction that early AI research could model. They solve most of the problems using fast, intuitive judgments. Artist's illustration of a crude outpost of Mars with AI-enabled vehicles is shown in this picture. Intelligence is another capability of intelligent systems. A machine with artificial general intelligence should be able to solve a wide variety of problems with breadth and versatility similar to human intelligence. Virtual assistants are programmed to speak conversationally or even to banter humorously. It makes them appear more sensitive to the emotional dynamics of human interaction or to facilitate human-computer interaction. Artificial intelligence as the driver of the new industrial revolution is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Artificial Intelligence, a change agent and disruptor of all aspects of humanity's endeavors, presented by Dr. Anyashola Ogundele, with focus points, artificial intelligence, and capabilities of intelligence systems. Thank you.